So that's actually what we are going to do, just to reiterate on whatever maybe, or to expand more on whatever you had learned earlier. So introduction to solar PV system. So you're going to, so the word solar PV stands for photovoltaic. And a photovoltaic, as the name suggests, photo means light, voltaic means voltage, which is connected with electricity. So we have a semiconductor material that convert sunlight directly into electricity. And we have various components that assist or aid the conversion of solar energy into electricity. So maybe we can introduce ourselves, what is electricity. So from the elementary school, or from the basic primary science, is that electricity is the flow of electric charge, where electric charge is electrons into brackets, or a stream of electrons or hole through a conducting material such as copper wire. And also an electric circuit is like a pathway through which electric current or stream of current flows. So that's the basic, like for us to have a megawatt power plant of a solar system. So for those engineers and technicians that are working on those power plants, is that they have understood the basics, and that's why we are just starting from the basic. For us now to understand the basic, through understanding the basic, now you'll be able to manage to design a megawatt of a system, or a gigawatt of a system, of a solar system. So by understanding that electricity is the flow of charge through a conductor, uh, yeah, so maybe they move from a region of high concentration to a region of low concentration. So we have two types of electricity. We have direct current and alternating current. So for example, the solar photovoltaic panels, or the solar panels, they produce electricity, which is DC, which is direct current. And then we have now a motor. So motor produces alternating current. So just that, the basic overview of the same. So uh, electricity that is being produced, it's being transmitted from one point to another through conductors. And also we do isolate this electricity in we do confine this electricity in the conductors. So one of the things, maybe for us, maybe we say we are going to use if you remember last week, I think I had mentioned that when we say that we use 1.5 mm squared for lighting, or we use 2.5 for socket, so that's the conductor. So the reason why maybe you need to understand, why do you use 1.5, why do you use 2.5 for socket, that's the conductor. So after understanding the basic, we will be able now to size. So also we know there's something known as cable sizing of our system. So we need to size the cables, and also maybe we need to understand the type of insulation that we are going to use for the cables, or the yeah, for the cables. So actually, a conductor is a material that allows free flow of electrons from one location to another. For example, good conductors that we normally use in electricity conductivity, we normally use copper and aluminium. So the other ones that, for example, silver, gold, water, and all that, is just an addition of materials that conduct electricity. But for them that we use for electricity conductivity is copper and aluminium. And the copper is the good conductor of electricity, and aluminium also. We normally use copper and aluminium. Aluminium, it's light, it's used for a long distance transmission. For example, we talked about Ketraco. I remember we talked about Ketraco and other KPLC. They use aluminium to transmit electricity in HT. We have, I believe you have ever heard of HT, high tension lines. So that's for aluminium. And then now we have insulators. So for us to confine or to restrict electric current into a conductor, we normally use insulators. And we have different types of insulators. And depending on where we are going to use our conductor, it depends which type of cable insulator that is being used. So for example, we have a type of insulator known as the rubber. We have plastic, glass, wood, and ceramic. But then now we can have a combination of these insulators to come up with a tangible type of insulator. So for example, we can have a metal insulated copper oxide. So we can have metal insulated copper oxide as a type of insulator. And also we can have XLPL type of insulator. So also we have a lot of types of insulators that exist. So also we have plastic as a type of insulator. And for example, maybe for outdoor cable, we have double insulation and all that. So it's very important to understand these type of conductors and insulators. So as you can see here, conductors and insulators, okay, so for example, we know for headphones and all that. So just the normal insulator, I believe most of us understand that is just giving you an overview on the same to understand. So also maybe for those individuals that will be engaged in that will go for electrical licensing exam, they normally ask maybe which type of insulator will you use for maybe sensitive areas such as gas station or petrol station. So we have an insulator known as XLPL. It's a type of insulator that is being used for conductors in a, for example, in areas that are maybe they can get fire easily. So for example, petrol station or depot where we get the gas and all that. So that is it. And then now we have voltage. So apart from now the insulators and conductors, so what is being conducted is voltage or electricity. So voltage is the electric potential difference between 2 points, and it's measured in volts. So when you talk about volts, high voltage or volts, it's now the currents that are being is the potential difference between 2 points. So under the form, I believe most of us are from electrical, or and maybe we have these basics. Voltage is equals to IR, where V is given in volts, voltage given in volts, currents given in amperes, and resistance given in ohms. So these are pictorial representation, and I believe some of us have come across this pictorial representation that volts is the force that pushes electrons, and the electron is current, and then ohms, which is resistance, is the force that opposes the flow of current. Yeah, and then now we have another terminology is current. Current is the flow of electric charge through a conductor and is measured in amperes, and also is represented by a symbol I. So this is just the basic electrical knowledge, and it's very important to understand it because we have something known as data sheet. In solar components, apart from the solar panel, we have batteries, and also we have inverter. So for us, for example, an inverter, they can talk about open circuit voltage or circuit current, voltage at maximum power point. So it's very important to understand the basics for us now to understand the data sheet, because the data sheet, okay, data sheet or the nameplate is the one that gives us what we design. We will design. Okay, maybe to talk about, maybe I can ask a question. What is a data sheet? Maybe is there somebody knows maybe what's a data sheet? If you know maybe what's a data sheet, you can raise up your hand and answer, or also you can write on the chat box. Yes, yes, you can go ahead. Samson. Okay, thank you. Yeah, a data sheet is let me say, it's like a document that has the parameters, yeah, maybe of a component or a device. So, for example, maybe let me use a solar module. It has some specification on it. So we have a data sheet and a nameplate. So it's very important to understand these maybe definition of current, voltage, and resistance for us to now to design from the data sheet. So we have resistance. Resistance is the opposition of the flow of current in a circuit. and also it's measured in ohms. So when we're having current flowing this direction, now resistance opposes the flow of current. Resistance opposes the flow of current. So apart now from voltage, current, and resistance, we have now power. So when you talk about kilowatt or megawatt, that's power. So apart from the joules, maybe some of us knows that power is rated by joules. So for our case in solar energy, we rate power in kilowatt. Now and energy, we rate it at kilowatt hour. So power is a current times voltage. Current times voltage, that is power. And for a solar module, I think I believe if you understand this, it will be easier for us now to, when we are going to talk about designing, when you're going to talk about maximum power point or voltage at maximum power point or current at maximum power point, you'll understand what do we mean by that. So that's the basic of designing. Actually, for us to go ahead, it's very important to understand this, that power is equals to current at maximum power point times voltage at maximum power point. So that's the formula. And then apart from power, now we have energy, where energy is power on a given time. So okay, and then so these are an example of a question on how to do some calculation on the same on power and energy. For example, we have CFL bulbs and also a refrigerator, a radio, a television, computer, and router. So we have these loads. Maybe we have 5 of them: one refrigerant, one radio, 2 television, and also we have 2 computer and 1 internet router. So maybe okay, so this is the quantity of power they consume. So if maybe we need now to get the total power rating for these appliances, is we times 5 times 13. So these are an individual bulb uses 13 watts. For us now to get the total power rating for all the 5 bulbs, we need to times them. So for example, if you times 5 times 13, you're going to get a figure here. And then now for us to get the energy, the bulb is operated for 5 hours. For example, we can say this, for example, they switch on the lights at maybe 6 and then they shut them at 10. So that's the 5 hours operating, and then the refrigerator runs for 15 hours, radio 4 hours, television 6 hours, and computer 6 hours, and also internet route actually. For this case, they're using it 12 hours. So if we're doing the calculation here, from okay, actually for us to for them to get this 13 is that they have times the maximum power, the maximum current and also voltage. Now they're getting 13 watts. So this 13 watts. So if you do the calculation, for example, 5 times 13, it is 65, and then 65 times 5 is 325. Is now 325. So if you do all the calculation, 1 times 700 is 700, and then 700 times 15 is 10, 500. So we have said that for us now to get the power, total power is quantity times the description of the load. And then if we now to get the total power for all the appliances, we need to add all of them. So if you add all of them, you're going to get as 1175 power. And then for energy consumption is 13.365 kilowatt hour. So for this one is rated as kilowatt hour. Sorry, it's watt hour. So if I say 13.3, it means kilowatt hour, but energy is rated in kilowatt hour. So I believe you have understood up to that point. Is there any question or concern? Yeah, any question or concern? Maybe if you are together, you can give a thumbs up. Okay, thank you, Nelly. Yeah, thank you, Namaya, Kennedy, and okay. Yeah, thank you so much. So that's power. Somebody has a question? Okay. Yes, yes. Mm-hmm. Okay. Okay. The what? Okay. So when we say a bulb has, for example, this bulb, an individual bulb has 13 watts, it means that this is the power that this bulb consumes. We have said here above that power power is given by current times voltage. So 13 watts, it means that for that bulb to light in 1 second instantaneously, it needs a certain, for example, it needs a certain current and a certain voltage for it now to light. So that's the power. When we say 13 watts is the power that is needed to make to do the job. Lighting a bulb is a job, or yeah, it's a job. So for us to light that bulb, we need a certain power. So when you say 13 watts is the power, is the is the energy. Look, let me say, yeah, is the energy needed instantaneously at that moment in 1 second to light up a bulb. I believe I've answered your question, David. Okay, thank you, David. So now we have electrical circuit. So an electrical circuit, we can have different types of electrical circuit, and a circuit has different components. So an electric circuit is a closed path through which electrical current flows, consisting of a source, conductors, a control device, and a load. So in solar system, we normally have a source, which most of the source of a solar system is the solar modules. We have conductors which are supposed to be correctly sized. We have control devices such as isolators, switch, and also circuit breakers. And also we have loads. Now loads, it depend with the type of maybe load that you are powering on. Maybe you can have a water pump or the normal appliances. So that's an electric circuit. So as you can see in this figure here, we have just used a pictorial presentation. So for this, here we have a load. So this is a load bulb. We have a source here as a battery, and then we have a control device, which is a switch. And this is a closed circuit, and then now we have an open circuit here, as you can see. Now, so these are like the single line diagram representing all whatever that we have discussed, and we have said that the source is the one that produces the electromotive force, and we have said the electromotive force is the potential difference and is the voltage that causes, is the force actually that causes the flow of electric charge or electric current. And then now conductor is a continuous path where electric charge flows, and we say that the most important conductor is copper. And then now we have the load. A load is an appliance that uses electricity. It can be, we have different types of load. We have yeah, we have different types of classification of loads. So it can be a bulb, a pump, a radio, a fridge, or any other appliances that uses electricity. And then now we have now a control device. Most of it can be a switch or a circuit breaker. Also, sometimes we can use contactors as a control device and all that. Also, we can have a photocell as a control device. I believe you have come across a photocell. So a photocell can be a control device. So that's a circuit. So the reason why we are doing this is that actually during sizing and designing, which is the ultimate goal of a solar system, that doing a proper sizing and designing to give a proper power or energy output, is that we properly design the source, which is the solar module, and we normally call it an array. We properly size the conductors, which is our cables, that we use the proper cables such as maybe 6.0 or 4 point something, or so the type of cable that we normally use for a solar system, depending on the size of the solar system. So we're going to size and design the conductors. Yeah, on the load, we are going to talk about the daily energy demand, maybe, and also the control device, how to size a circuit breaker. And I'm reiterating again, when we say we need to use maybe 6.0 amperes for lighting, or we are going to use maybe 10 or 16 for sockets, or maybe that 2 or 20 for socket. How did we arrive at 20 uh, amperes? How did you arrive at 63 amperes, that this is the circuit breaker that you are going to use? Or how did we arrive that we are going to use 1000 VDC surge protector? So that's the thing that you are going to look at on the sizing after understanding these basic components, or yeah. And then now we have a closed circuit. So we have three types of circuits. We have a closed circuit, open circuit, and also a short circuit. So a closed circuit is a loop that allows appliances to receive current and also to remain connected to the voltage source, as for example this figure here. So this is a closed circuit. A closed circuit is when the control device is switched on. Yeah, is switched on. So as you can see from this figure, so for this case we are using a battery, a dry cell, and then we have a load. Yeah, I believe we are together up to that point. If you're together, you can give a thumbs up. Yeah, thank you, Kennedy, David, Clarice, and Alex, Gibson, Ellie, James, and Thomas. Thank you for that thumbs up. So an open circuit is an incomplete circuit that there is no flow of current through it. There's no flow of current through it, as is shown in this figure here. So this is an open circuit. So if maybe a data sheet can say open circuit voltage. So when it says open circuit voltage, what does it mean? So when we're going to talk about data sheets, uh, after understanding that an open circuit, it means that uh, the solar panel or the solar module is not connected to what? To a load, as you can see here. The next thing is the short circuit current, or sorry, short circuit, a short circuit. So a short circuit is a type of a circuit where we provide an alternative route between the live and the neutral, or the positive and the negative, by bypassing the path through the load. So that's the short circuit. And actually a short circuit is a dangerous circuit, in the sense that when we provide this alternative route through between the live and the neutral, the positive and the negative, actually it's like a path of low resistance, of nearly zero, or less or nearly zero resistance. And through this, it causes a lot of current to flow through the conductor, and at times now it causes like overheating. So when a lot of current flows through a conductor, it causes overheating, and then this is what can cause maybe fire. When we talk about electric fire, actually it's because of short circuit. So let me read from this statement. It says that because of low resistance, the current becomes extremely large. In such a condition, no current flows through the load and or the entire source. And then the current also, yeah, so the current that is flowing through that is known as the short circuit current. So actually this is a very dangerous sometimes, maybe when it exceeds a certain time. So, and I believe most of us have come across short circuits and have experienced short circuit, maybe maybe by themselves while conducting maybe some installation, or they have come across through it on a video. Yeah, and I believe you have understood. So, for example, the cases that we say that there's an electric fire, it's because of most of the short circuit. And we have a device actually that also it's very important device while doing the sizing and designing of any electrical system, not only the solar system. We have a circuit breaker. So one of the importance of a circuit breaker, as the name suggests, is to disconnect the circuit, maybe peradventure when we have a short circuit. So a circuit breaker does that. One of the things is that when we have a short circuit, it trips. Another thing is that a short circuit breaker does is it prevents over voltage or over current. So for example, if you have given a circuit breaker for your lighting, that you have designed this circuit breaker to be for lighting, and we expect that the most or the maximum current that we can draw from this circuit is 6 amperes. Now when we exceed the 6 amperes, maybe you some I know some individuals, if you are a comrade, maybe your landlord, yeah, I know some landlords are very maybe you are sharing some token, so they are deciding that, I know maybe some of you are using coils. Yeah, they're using coils for cooking because you are sharing the meter or the token. Now the landlords now are wise, so they are saying that you need to use the socket to charge your phone and laptop, not to use it to cook by using the electrical coil. Now they are changing the circuit breakers from the 20 amperes to 6 amperes, because 6 amperes can support your laptop charger to charge. So that, and for example, now when you maybe you connect your coil or to cook, or maybe when you use the iron box, it trips. I don't know if somebody have experienced that. So a circuit breaker is like a control device to prevent over voltage or over current, or to draw a lot of current from a circuit. So that's one of the ways that most of maybe landlords they are using to mitigate those individuals that maybe if you are sharing an energy meter, they are using a low rated circuit breaker. And maybe also to give like a statement is that when buying the circuit breakers, it's very important also to consider the brand, and also because some circuit breakers are not actually circuit breakers. When they experience a short circuit or an over voltage or an overcurrent, they will not trip because they are not properly rated. So it's very important to buy from a recommended brand of circuit breakers. So that's one of the things that a circuit breaker does. So also, apart from the short circuit, apart from the closed circuit and open circuit, we have other types of circuit which are also are very essential and very important in any system. Actually, the solar system, when we call it parallel and series connection. When we talk about parallel and series connection. So, for example, when we talk about series connection, is when we connect. Maybe somebody can tell us uh, what is a series connected. Maybe let me use batteries or solar panels. When we say a series connection, what does it mean by a series connection? Yes, what do we mean by a series connection? Yes, somebody can write on the chat box or can unmute and speak. Yeah, thank you so much for that. Yeah, thank you so much for that input. Yeah, true. Series connection is when you connect your solar modules or when you connect your batteries, uh, the positive to the negative, and then the negative to the positive. So that's the connection. So it's very important and very critical to understand the parallel series connection of batteries and panels, because now also to say that when we are going to come up with a megawatt of a solar system, or when you're going to come up with a kilowatt of a solar system, is that it's actually a certain number of solar modules. Maybe we can talk about 20,000 solar modules. You have connected them in parallel and series connections. So we are going to talk about that as we continue. Yeah, thank you for the input. Um Thank you for the input. So actually, after understanding that from the basic electricity, because the datasheet actually it tells us there's a certain range that we need to connect our solar modules. Maybe we need to connect them. Maybe the maximum number of solar modules that we can connect in series is maybe 25 or 20. So that's one of the things that we need to understand, because you're not supposed to exceed a certain voltage or a certain current. Okay, let me go to this one. So in a series connection, or in a series connection, all components are connected after another component in a single path. The same current flows through every point through by the supplier, or so. For example, this is the pictorial representation that we are connecting all the solar modules in a single line, and actually the current is the average. Yeah, the current is the average. I mean, the current is not the same. Okay, just to say the current is the same throughout is relatively correct, but actually, what happens? The current is the average. What actually happened? The current is the average. For example, when we are talking about, for example, you can take this, for example, an example like we can say this is 11 amperes, 11 amperes, and 11 amperes. So for the current that is flowing through for this load is that 11 plus 11 plus 11, which is 33. And then now we divide by 3, we get 11. So that's how we normally do, like when we connect in series for current. But now the voltage is the summation. So if maybe the voltage for this appliance is maybe you can give it maybe 50, so it's 50 plus 50 plus 50, which is 150. So that's what actually is what actually happens. So for the parallel connection is when we connect all components across maybe one point, and that actually the voltage is the same. So the voltage across all these loads is the same, but now the current is now the summation is the opposite. I believe it's very important to understand that, and I believe you have gotten that concept, that in series, the current is the average. Now the voltage is the summation. But for this case, the current is the summation, and then the voltage is the average, like is the same. Let me say in quotes is the same. Actually it's not the same in that sense, but is the average. I believe that's okay up to that point, and if it's okay you can give a thumbs up. Yeah, thank you Kennedy, James, and Job, and Ellie Gibson. Yeah, thank you so much. So maybe is there any question up to that point? Yeah, thank you Mercy and Gibson and the rest. Okay, so parallel and series connection. So these are an example of the same what we have talked about. That for example we have these solar modules. So an example of solar modules on parallel connection, we have said that parallel connection, you take the negative and the negative and then the positive and the positive. That's the parallel connection. So in parallel connection, it increases the current. So is the summation. So if we assume that these solar modules are 12 volts rated, and their ampere is 5.5 amperes, power is 100, then the effective or the effective uh, the effective current voltage and wattage is 12. We said is the average, current is the summation, and then power also is the summation. So that's actually what happens, and an array is formed. So an array is formed. So when you connect solar modules in parallel, we get an array. But when you connect with them in series, we get a string. So the next connection is in series connection, as you can see. So series, you take the positive to the negative, and then you can have, take that's the positive. If you have two modules, you connect the positive to the negative. Now the current is the average, and then which is 5, and then the power is just also the average in series. Sorry, the current is the average, and then the voltage is the summation, as you can see from these figures. So we have another example. Maybe we have these 4 solar modules. So what will happen is actually we are going to get 48 if you connect them in series, 48 volts, and then the current is 5 amperes, and then the power is 40 watts, 400 watts, sorry. So I think up to that point, the point that we are discussing, you have gotten it. So if also we are together up to that point, also you can just give a thumbs up. I know if you are together. Okay, thank you so much. So I'm reiterating again, the reason why we need to understand the parallel series connection is that we are going to develop arrays. We're going to develop string. That this array and string are the one that are going to make up a solar system, a megawatt of a system, or a kilowatt. So after understanding these fundamentals, that when we connect in parallel, what happens to current and voltage, it will be easier for you now not to blow the inverter, or maybe to come up with a system that can explode. We are not maybe we are engineers who are coming with solution. We are not bomb experts. So that's all for that basic electricity on a parallel series connection, and also voltage, current, and resistance. So apart from that, we have appliances that we need to understand them, because actually they are very, very important appliances or equipments in any electrical system, in the sense that we need to use them to measure the voltage, current, and resistance. So for example, we have a DC clampimeter. It's a very good appliance that is used to measure specifically DC current without like having direct contact with the appliances. So as you can see, these are clampimeter. We can have both DC and AC clampimeter. So these are both DC and AC clampimeter. So the reason why is that, as you can see, so these are DC AC clampimeter. So I don't know if you can see here. So we have, if we have A, so stands for current, and then on the top here, if you can see, we have this line, and then we have some dotted line. So this stands for DC current, and then AC we normally represent by a what? A wave. So these are DC AC clampimeter, and also we can have an AC clampimeter only. So for example, by clamping around a conductor, it detects the magnetic field around it, and then we can read the current that flows through the conductor. So so I think that's how we normally use, and we normally set these are knob, and all of us actually should maybe try to come. If you don't, you have never interacted with a multimeter, ensure you interact with it. So it's very important, and also know how to use it. So we need to you turn this knob to DC or AC voltage and all that. Okay. We have also a digital multimeter. So a digital multimeter is a versatile instrument used to measure various variables or values or parameters. We can use to measure both AC and DC, and from capacitance to resistance to continuity to frequency. Yeah, also even to, I don't know if you have ever known that you can use a multimeter to measure temperature. Yes, maybe to ask, has any individual have ever used a multimeter to measure temperature? Hmm? So if you have a multimeter, go and check. We have a slot of temperature. So a multimeter, as the name suggests, multi means multiple measurements. And actually, it's one of the ways. Maybe for those, I believe, for those individuals that will go for EPRA licensing, maybe you will find a question maybe to describe how to use a multimeter, or you'll be given a multimeter to do some test. And actually, this multimeter, I can say maybe for the first time users, maybe when they're measuring current and voltage, maybe for example, we have common here. I believe you see this common, and then we have for the voltage, and then we have for the current. So when measuring voltage, you are testing leads. It should be on common and voltage, and then when measuring current, it should be on common and current. And I believe some of us here maybe they don't know that, and maybe when you are measuring current, your testing leads are common and on voltage. So it's very important to understand how to use testing equipments, because any project that you are going to commission or install, you must actually measure voltage and current, and also continuity, resistance, and all that. Yeah, because it's very important when coming up with any system, you measure all those parameters. You measure all those parameters. Yeah, and ensure maybe to get a multimeter on the same. So apart from multimeter, we had talked about some instrument. I don't think, okay, I don't know. Okay, they're not here. So we have other instruments. Okay, actually we talked about them on the last presentation. We have earth resistant tester, insulation resistant tester, phase rotation meter. Also most of the equipments that maybe we need to acquaint ourselves with, mostly on earth resistant testing, earth resistant tester, we need to acquaint ourselves with. So another components, another topic, subtopic that we are going to tackle for the remaining around 40 minutes is, or 30, okay, I think it's 30 minutes, is on now the solar resource. So actually the sun is the closest star, and the sun is the main source of energy. And I believe most of us have been hearing of this, that the sun is the main source of energy. Uh, Actually, the sun produces energy of around 3.8 times 10 raised to 23 kilowatt of energy. So this energy is being produced in the nuclear reactions. But actually, what energy that we receive on the earth is small energy, in the sense that we are getting of it 1.73 times 10 raised to 16 kilowatt. Because this energy, when it's being dissipated from the sun, it experiences some losses on the outer heaven. So actually, we have okay, atmosphere. Okay, we have actually three heavens. We have the atmospheric heaven, where it starts from the ground to the um. If you remember your geography, we talked about is it ionosphere? So that's the atmosphere, atmospheric heaven. Now we have now the starry heaven, where we have our sun, which is the source of energy on the earth. So that's the starry heaven. Now the third heaven, it is normally known as the paradise heaven, for the, yeah, the paradise heaven, where they say where God lives. So the power that we receive on the earth, on the that is on the atmospheric heaven, In the atmospheric heaven, we have a lot of components. Yeah, we have dust, we have clouds, we have uh, we have a lot of other components that leads to the losses that we are experiencing for us to get this energy. So okay. So these are pictorial representation on the description of energy, that the sun is the ultimate source of energy, where we get the sun energy in form of heat through, we can get in solar thermal conversion, where we're going to talk about solar water heating. Solar water heating is form of solar thermal. Also, we have solar drying. Yeah, solar drying facilities, solar dryers, or solar concentrators, or concentrated solar power plants. Also, the sun is the source of energy. When we talk about precipitation, uh, apart from precipitation, we can have wind, also wave, we can have tidal energy, and also running water. And also we have now, through photosynthesis, actually here we are getting energy, the biomass. And now on the biomass, we can have the biofuel, and I know some individuals have interest on biogas or bagasse. I believe you have heard of bagasse and biogas and all that. So it's through the sun. For example, in Momia's sugar company, I don't know if it exists, or maybe Thika power plants. We have those power plants that uses thermal, and this thermal energy is being used, is being produced by maybe some biofuel. So apart from that, we can have now the fossil fuel here, the fossil fuel, and then also now our interest on the solar photovoltaic, which is the most interest, that the solar panels, the semiconductor convert sunlight into electricity. So that's the general overview of the same. Okay, so the types of solar system, we have on-grid, off-grid, and hybrid, which we are going to define them. What is off-grid, on-grid, and hybrid, and the components that are rated to on-grid, off-grid, and hybrid. So the basic solar components that we have, this basic solar components that we normally have is solar modules, and we have said that the solar modules convert sunlight into electricity, which is the direct current. So these are the solar modules, and we have different types of solar modules. We have, maybe somebody can tell us, you can write on the chat box the types of solar modules that we have. I know maybe some of us have knowledge on the same. You can write on the chat box. We have polycrystalline. Yeah, true. Thank you. Any other? Any other type of solar modules that we have? Monocrystalline, polycrystalline, thin film, bifacial. Yeah, thank you. Yeah, thank you so much. Thank you so much for that input. Also, we have also building integrated solar PV. We have building integrated solar PV. Uh, yeah, thank you so much. So on solar modules, you have said they convert sunlight into electricity. Now we have inverter, and inverter actually converts direct current into alternating current, not necessarily from 12 volts to 240, but we can have inverters that convert maybe 48 volts, 51, or even 100 volts. So it depends. We have low voltage inverters and high voltage inverters. So those are the inverter, and then now we have the batteries. So on inverter, maybe to say we have different inverters can be classified into three categories. Number one categories can be classified on maybe the type of connection. So we can have off-grid, on-grid, and hybrid inverters. That's the first category. The second category, we can have string inverter, central inverter, and microcontrollers. So that's the second category. Now the third category, we can have modified and also pure sine wave. So those are like the three. Even we can have even up to four categories. So on hybrid and on-grid inverters, we can have inverters known as the battery chargers. So we have those categories. So yeah, I think up to that point is very okay. So the next point is on batteries. So the function of battery actually is a storage system that stores solar energy for later use. And on batteries, we have a lot of different batteries category. We have lithium batteries, and also we have lead batteries. So on lead acid batteries, okay, what's the difference between high frequency and low frequency inverters? So on high frequency inverters, so these are the kind of inverters that when you introduce an induction, okay, if you remember, I talked about we have different types of load. Let me talk about an induction load. So an induction load, for example, is maybe when heating elements are example of induction loads. So for high frequency inverters, they are normally like they don't support like induction loads. So if you use if you use them if you use them with induction loads, you're going to like to damage the high frequency inverter. So they are not able to sustain the induction loads. Now for the low frequency inverter are a type of inverters that can support induction loads in the sense that they are made in a such a way they have heat sinks to like they are made in a such a way that they can support the induction loads, and most of them are made up of heat sinks. Induction loads draw a lot of current, and if you remember, we said that when a lot of current is being drawn, maybe in a conductor, it causes a lot of like heat. So the low frequency inverter are made up in a such a way that they can support this they can support induction loads. But for the high frequency, they are made up of like they can support the normal loads, not the induction loads. I believe I've answered your question, Kennedy. If you have answered your question, you can give a thumbs up. Okay, thank you so much, Kennedy. Yeah, so also it's very important to understand the type of loads that your client has for you now to recommend which type of inverter would you use. Is it a low frequency inverter or a high frequency inverter? Yeah, thank you. So on the batteries, we normally have two types of battery. The commonly known battery, we have lead batteries and lithium batteries. And lead and lithium batteries, they are categorized into various components. For example, on lead batteries, we have lead acid batteries, and then we have the gel battery. Also, it's lead as is lead, but it's gel batteries. And then now for the lithium, we can have lithium ion, we can have lithium phosphate, we can have lithium manganese phosphate, and all that. So we have a lot of uh, varieties of batteries apart from the lead acid. We have the lead gel battery, sealed gel battery. And then for the lithium, we have lithium ion and lithium phosphate. So apart from that, we have other categories of battery apart from lead and lithium. We have other categories such as float batteries and other types of batteries. But the most known commonly used batteries in solar energy is lead acid, gel, and also lithium ion. But nowadays, I normally recommend as an individual, maybe if you're doing any installation, you go for lithium batteries because actually the price is going down. And also maybe to add on, lithium batteries are one of the batteries that are normally used in immobility. I know some individuals have interest in immobility, so lead acid battery are not used in immobility, but we normally use uh, ion, lithium ion or lithium phosphate batteries for immobility. So another component is that another component we have grid connection. So yeah, for okay, we have something known as BMS, the battery management system. So for battery management system, you find that the lithium ion are the one that have the battery management system that is being integrated with them. But I've observed some gel battery. Nowadays, they are coming up with having the battery management system. So the function of battery management system, the BMS, is to prevent overcharging and over discharging of a battery, and also to not only that, to balance the voltages of of the cells. So the batteries are made up of small cells, and each individual cell produces 3.6 volts. So we need to balance the voltages across these cells. So we use a BMS. And also I've seen, I think, yeah, today I was watching a video on YouTube, maybe about a parallel and series connection. So there's this engineer was connecting some batteries. The batteries were not lithium ion, but he had connected around uh, around 20 batteries, and he used an external BMS. So the batteries were gel batteries. I believe I've answered your question and given an input on the same. So the type of solar systems. So a quick introduction on the three main types of solar system, where we have on-grid, off-grid, and hybrid. So on the on-grid is grid connected. So on these sticks we have grid connected. So it's grid connected, and also grid connected. On-grid doesn't have battery storage, and mostly is best used in urban areas. So the cost for grid connected is low, in the sense that actually the battery is one of the most expensive component in a solar system. Yeah, the battery is one of the most expensive component in a solar system. So it's low cost because we don't have battery. Now for off grid, it is not connected to the grid. It has battery storage. It's suitable for both urban and remote areas, and also the cost is very high, in the sense that we need to buy a lot of batteries and also the solar modules. So now we have the hybrid. As the name suggests, is a connection of maybe hybrid. Let me say hybrid is a connection of two or more sources of energy, in the sense that we can have the grid as it's being connected, we can have battery storage, and then we have the solar modules, we can have wind, we can have genset or generator. So that's the hybrid system. So actually it's best used in areas where we have unstable grid, and also their cost is like a medium compared with the rest. So each system has its own advantage and others have disadvantages. So depending on the location and also the budget. So um, to go to the next point, so there's a question that in newer technologies they have both in old technology. Okay, okay. So somebody is saying that the inverter has integrated BMS. So actually, you find that yeah, for the hybrid inverter they come with BMS. Uh, okay, maybe I can do a research on the same. Maybe I don't know if Michelle you are meaning the MPPT. We have different between charge controller, which is the MPPT, and the BMS. So the BMS mostly is found in the batteries. Yeah, it's found in batteries, the lithium batteries. But I can do a research on the same, where you are saying that the hybrid inverters have BMS integrated. I have no idea on that, but I can do research. But what I know is that the hybrid system have the MPPT integrated, rather than the older inverters that had just it's an inverter. Now you need to integrate another charge controller outside, which is maybe in MPPT. Yeah, which is MPPT. So on grid system, yes, yes, yeah, I believe so. Yeah, she was talking about MPPT. Yeah, true. Kennedy. Yeah, thank you for that. So maybe now to gist down the systems on maybe grid connected or on grid. So another name of grid connected is on grid. Is that an on grid system is a type of system where we have connection to the grid, just the solar modules and the inverter. So as you can see from this picture, we normally have the solar PV array, a grid connected inverter. And then now we have a meter and now the grid. So this is the limiter. Limiter, we call it the CT, the current transformer. So maybe we have different types of grid connected system. So we can have a grid connected system in the sense that you are providing power from your solar modules to the house and you don't supply to the grid. So now you need to have this limiter, the zero expo meter or the current transformer, to prevent power feeding into to feed power into the grid. Now, apart from that, so this is the type of grid connected. Also, we can have a type of grid connected where you provide power to your house, the excess you sell it to the grid. Actually, you're not going to be given money, but you're going to be like, they do some cancellation that maybe at this point you supplied 200 kilowatt hour to the grid, and maybe now for this case you have used 200. Now we have cancelled that, you're not going to pay a certain money to the grid. So how is the integration between renewable energy from solar PV to the grid or existing power system done? I think Kamau is what I've just explained here. So the integration of power or renewable energy is that maybe you can have a grid connected system, in the sense that you can supply, maybe you can come up grid connected system or on grid system is not necessarily that you supply to your house. For example, we have a system in Garissa, the biggest system that we have in Kenya, known as the Garissa Solar Power Plant, around 54 megawatt. Yeah, 54 megawatt. They normally produce electricity and they now sell it into the grid. We have other power plants in Eldoret, such as Idocel and Radiant Solar. Let me show you on the same. So we can supply power to the grid from various power plants. So for example, the integration between the grid and the renewable is that we can just have a grid connected system, in the sense that you're producing power and then you supply to the grid. So for example, I've talked about Garissa Solar Power Plant. So let me show you. Okay, so we have Garissa. I hope you can see my screen. So we have this Garissa Solar Power Plant. I believe you have seen my screen. So if you can see my screen, you can give a thumbs up. Yeah, thank you, Mercy, Job, Stella, Kennedy, Alex, and Brian, James, and Obai. So these are a grid connected system. This system, it doesn't have energy storage system. It just have some solar panels, and these solar panels are connected to the grid. These are grid connected system. So solar panels and then connected to the grid. So if you go to the official website of REREC, if you remember on the first presentation, we were talking about REREC as an association that we need to follow in maybe in our social media. So let me search for you REREC. We are going to see about the Garissa power plant. Okay, let me search Garissa power plant, and then we are going to see what REREC says about the solar power plant. Garissa. So it's 40 megawatt, or is it 40? Okay, let us confirm. So it's 50, sorry. Yeah, it's 50. So this is Rural Electrification and Renewable Energy Corporation. So it is one of the body that was spearheading the project. So they are saying that the 50 megawatts Garissa Solar Power Plant, so this power plant is the largest grid connected, underline the word grid connected, solar power plant in East and Central Africa. So it's a grid connected. So the one who has asked about grid and renewable energy integration. So we have that one here. So this is the power plant, and it was launched in the year, is it 2019, by President, it should be President Uhuru, who launched the project. So you can do some research on the same. So it has 600 inverters. Oh, sorry. It has some inverters. So there are some specification about the project. Oh, here is the, it has this substation, yeah, 50 megawatts transformer, uh, and all that, CCTV, number of solar modules they have been given here, and transformer. So this is the capacity 50. Where is it? I'm looking for the number of solar modules. So this is an example of a solar system that is grid integrated. Also, we have this other type of solar power plants. We have Idosol that is in Eldoret. Is a solar grid connected integration. Okay, let me go to it. Sorry. Okay, I need to go to this. Okay, so I'm going for this one, Eldosol. So it's a project in Eldoret. I believe it should be in Keses. So these are the solar power plant. I believe you can see it. If you can see, you can give a thumbs up. Yeah, thank you. So the one who was talking about grid integration. So we have this solar power plant, Idosel, and then we have this one here. So we have two of them that are adjacent. We have that one, Radiant. It should be Radiant. Let me say. Yeah. So we have this one here, and we have other one here. So these are 40 megawatt, or totals to 80, and all of them they supply to the grid. Yes, a question? Yes. Okay. So those are the types of solar system that we have. So apart from that, we have other types of solar system. Let me go to, yeah, please mute your mic. So we have this type of another one in Two Rivers. I believe some of you know Two Rivers. So we have another solar, but these are grid connected system in Two Rivers. So I believe, yeah. Do you know Two Rivers? If you know Two Rivers, you can give a thumbs up. Found in Ruaka, Kiambu County. Yeah, so as you can see on the roof here, we have some solar panels. I believe maybe we are going to organize a field visit to maybe one or two this of the solar power plant after the training, maybe in the month of, I don't know, we are going to organize a field visit to see on solar power plant. Maybe we can plan on the same. So maybe you can plan to go to maybe to Two Rivers, or any power plant that is in Kenya. So this is Two Rivers, as you can see. So it should be 40 megawatt if I'm not wrong. Not really, but so that is Two River. We have other types of solar power plants. So we have Tatu City. Yeah, also we have Tatu City having some solar power plant. We have Blue Nile rolling in industry area. As you can see, those are the solar power plants that we have. We have this one, Kevina industry area. So we have Broadway industry area, East Africa. We have this one, Suguna Feeds. As you can see, those are the power plants. We have Thika Clothes, yeah, there. Yeah, we have a lot of power plants. Apart from this one, also we have the mighty, about Strathmore University. So those are types of grid connected system that we normally have. So yeah, I think up to that point it's okay. So maybe let me go back to, I believe you have learned something. Let me go back to the presentation. So if you have learned something, you can give a thumbs up. Okay, thank you. So that's the grid connected system. And so the grid connected system is solar panels, inverter, net metering. It doesn't have the battery. So that's the grid connected. How it works is that actually for the grid connected, when there's no power, there's no the grid, it doesn't work. When there's no electricity. So grid connected, it means that when there's no electricity, you cannot use it. So it works hand in hand. It's slave. The solar modules or the inverter is slave to the electricity. So if you don't have electricity, you cannot use the solar modules. Yeah, so that's the point. And then now, so I think, okay, advantages. Okay, let me go quick because I've seen time is almost out. So we have off-grid system. So off-grid system, they have energy storage system. We have solar. We can have a charge controller, or we can have a hybrid system or hybrid inverter. And then we have a inverter and all that. So this is on off-grid system. So it normally has solar panels, charge controller, inverter, and batteries. So the function of charge controller is to regulate the overcharging and over discharging of the battery. Now the inverter AC, DC to AC batteries to store electricity. Then how it works. So just the same, like we get generate electricity, and then when we generate electricity being stored in the battery through the charge controller that does the charging and over discharging. Now the usage, we normally use it via the inverter. So that's how it works. So these are the advantages, that it provide electricity in remote or rural areas independent from the grid outages and also instability. And also it promotes energy and promotes energy self-sufficiency and sustainability. So that's it. Disadvantage is actually it's expensive in the sense that we need to buy a lot of batteries. We know there's something known as the days of autonomy, where we need to buy a lot of batteries to support the days in which where you don't have maybe sunlight. Okay, so apart from the on-grid, off-grid, now we have the hybrid inverter. So the hybrid system, in the sense that you combine one or two sources of power, in the sense you can combine grid, solar, wind, genset, and also battery. So as you can see, for this case, we have combined solar. We have combined solar panels. Inverter is here. We have the batteries. So, and also we can have now the grid. So this is the hybrid system. Solar panels being constant, grid connection, hybrid inverter, battery, and also you can integrate the wind, genset, and all that. So that's form of hybrid system. The next thing, so that's the advantages, just the normal advantages. Disadvantages is expensive. So the comparison, I think we have done this one earlier. Just the same comparison. So application, I think we are done about it. So apart from that comparison and all that, so we have the cost and investment analysis, in the sense that the on-grid is the cheapest type of system, in the sense that you don't buy the batteries, followed by the off-grid, now followed by now the hybrid, which is the premium, in the sense that you need to integrate various power sources. So maybe if we invest on our system, maybe it can have 3 to 4 years of return. We have a return of investment, or maybe even up to 10 years. So it depends with your type of system. So we have some maintenance tips. It's very important as an installer or as a technician or as an engineer or a client. When you do solar installation, it's good to do maintenance, in the sense you do panel cleaning. You use soft brooms or soft materials to do the cleaning. It's recommended you do it quarterly, because if you don't do it quarterly, it means we can have non-removable stains on the solar modules, which reduces the efficiency. And also it's very important to check the battery health. Actually, the lithium batteries, you can know their state of charge or the state of health through the battery management system, and maybe how many cycles have you used So on the data sheet, we are going to talk about depth of discharge, charging cycle, and all that. We are going to talk about all those details that are found in the data sheet. Also, we are going to do some maintenance on the inverter and wiring, and also it's good to do some documentation of your system, for example, on the manuals and also troubleshooting. And also when doing the installation, it's good to have the drawings that will show that your system is connected in this way and that way. And also maybe the values that you got during testing and commissioning. So the values that you got for the earth resistant, the insulation and all that. So yeah, that is it. For example, on the future trends on a solar system, we have now the smart grids. So on the smart grids, I believe we have some individuals that know about PLCs. Maybe somebody can tell us what is PLC and what is SCADA. What is PLC and what is SCADA? So PLCs are programmable logic controllers. So for megawatt and also maybe another kilowatt, so we are having systems that are integrate AI. We have AI integration, where we have now the PLCs and SCADA doing their part in the sense that we program these PLCs. We program these programmable logical controllers, and SCADAs, that is superficial control and acquisition data and data acquisition. So yeah, superficially control and data acquisition. So they have been trained by AI. Maybe when this happens, when that happens, what is supposed to be done and all that. So that's one of the things that maybe we are working, maybe as individuals, maybe we're in the solar industry are working on to have AI integration on having smart grids. Not only the smart grids, also the smart solar power plants. I believe actually nowadays we have KPLC, which is in Kenya, the national grid for the company that is responsible for the national grid, KPLC, Ketraco, Kenjin, they have this, yeah, and we have some individuals that are specialized on this, on SCADA, on PLC, and it's very important also for us to specialize on the same. So we have now batteries that are maybe have long lasting about maybe 15 years. Now we have EV integration. We talk about carports and also energy independence. So I believe that's the end of our today's training or presentation. Believe you have learned, and if you have learned, you can give a thumbs up if you have learned, and also yeah, thank you so much everyone for joining. So we welcome you all to the next training on Tuesday next week, where we're going to talk about now on installation. Actually, we're going to talk about site visit, designing, installation, and all that. So please ensure that you join. And also maybe as a maybe an token of appreciation, I would like maybe as I'm going to give back the mic to Clarice. So as a token of an appreciation, maybe as an individual, whatever you have learned, I request that as a token of appreciation to the organizers, that is IEEE and Power and Energy, maybe you can do a post on maybe 1 point or 2 points that you have learned, uh, 1 or 2 points that you have learned, and then remember to tag IEEE or Power and Energy to the CUT, KU, and also don't forget to tag maybe the organizers, that is John, Kralis, and also you can tag Torchbearer and also Dalton on the same. Yeah, thank you so much, and back to Clarice. Please ensure you do that. Maybe you do a post on LinkedIn and then you say whatever that you have learned. Yeah, so on the DoD, what's the typical? Okay, for gel battery, it's 70 to 80%. Yeah, thank you so much, and uh, I give the mic back to Clarice. Yes, yes. Okay. So actually, you find that most of our transmission lines are AC. So that's why we have now the inverters. Yes. Hmm. Yes, yes, we have some HV. So at that time in 20 should be 2019, we didn't have that one. So and that's why they needed to have now the inverters and all that. Okay. Okay. Thank you so much, everyone, and I'll see you on next week. And also, don't forget to make a LinkedIn post and tag us. Yeah. Thank you.